4.8, solving problems with trigonometry. Alright, so these are obviously word problems. Some of them will give you a picture, some of them will not. But we will typically be drawing a picture if we can to simulate what we're looking at. So number 2, from a point 100 feet from its base, the angle of elevation of the top of the arch of, I'm changing the name of it because I can. In Rome, Italy, is 34 degrees, 13 minutes, 12 seconds. How tall is this monument? So I did the degrees, minutes, seconds with college algebra yesterday. They're like, why are we going to need this? I was like, for word problems? They're like, we're going to do word problems? Yes, you are. I was like, especially if you take pre-cal next year. Alright, so things that we know. It's 100 feet from its base. The angle of elevation is 34 degrees, 13 minutes, 12 seconds. And we're trying to find how tall is this monument. So I'm going to draw a picture. So my angle of elevation is going to be this angle here. This is the base of the arch over here. This is 100 feet. And I want to know how tall the monument is. So I care about this side here. So I need to convert the degrees, minutes, seconds all into decimal. So how would I do that?
34 plus 13/60 plus 12/3600.
Yep. Now, I need a trig function that relates the angle that I have in the other two sides. What might that be? Tangent. I need to use the stuff that I have.
Oh, gotcha.
I was going to say tangent, but I was lagging and didn't say anything.
So the tangent of 34.22, make sure you get your calculator back in degree mode if you're in radian mode from the other day, equals opposite, so x over adjacent 100. So x equals 100 tangent of 34.22. And just go to 2 decimal places if it's a decimal. And the units are feet. So that's how tall it is.
That was simple.
these word problems, like just figuring out where to put everything, all the information. They're not hard.
These just scary word problems and stats.
Yeah, these aren't scary. I'm gonna do 3 for you, but I'm gonna come back to it in a second. I'm gonna do a couple other ones first. 4. Alright, this is a long word problem, so I'm basically just gonna write out critical information because it's a longer one. So this is finding a baseball stadium's dimensions. The top row of the red seats behind home plate at the Cincinnati Riverfront Stadium is 90 feet above the level of the playing field. So 90 feet above level of the playing field. The angle of depression to the base of the left field wall is 14 degrees. How far is the base of the left field wall from the point of the level ground directly on the top? So the first two things are what we're given and what we'll use to solve. The last thing is what we're trying to find. Basically, I just removed all the unnecessary stuff about the Cincinnati Stadium and all that stuff that you just didn't need to write. So, I've got a baseball field. Assuming you at least kind of know what a baseball diamond looks like.
It's making me think of either a slice of pizza or snow cone.
Yeah. Alright, the top row of the red seats behind home plate is 90 feet above the level of the playing field. So this is going to require a little bit of imagination, but basically we've got a seat right here. It's 90 feet above the level of the playing field, so I'm going to kind of like draw it into the stadium so you can see it, but no, it would be technically going like straight up out of the paper like that. Okay, so I'm going to draw it this way. So 90 feet. The angle of depression to the base of the left field wall, so that would be over here, is 14 degrees. So imagine all of this is like being stood up on the side of the stadium. So this was what it would actually look like, basically. So I'm going to basically pull this triangle out of here for the sake of looking at it. So this angle here is 14 degrees, 90 feet here. How far is the base of the left field wall from a point on level ground directly below the top row? So basically, I've inverted the triangle. Instead of it being going down this way, it's like, and the level part being like on the top, we're making the level part on the ground, is what I'm doing. I'm just like inverting the triangle. So I'm trying to find this piece here. So, what trig function associates these things? Tangent. You're going to find that's pretty common. So the tangent of 14 degrees is equal to 90 over x. We can just swap those, so x is equal to 90 over the tangent of 14. And always make sure you put units on there. Gotta have feet.
Yeah, I was waiting for one to figure it out. But then they'll do the math.
Alright, this next one they give you a picture, but I'm still gonna draw it anyways, because I'm gonna write on it as well. But number 8, finding the height of the tallest chimney. The world's tallest smokestack at the International Nickel Company in Sudbury, Ontario, casts a shadow that is approximately 1,580 feet. How long? Is approximately 1,580 feet long when the sun's angle of elevation measured from the horizon is 38 degrees. How tall is the smokestack? So, it's 1,580 feet long. Shadow. The angle of elevation is 38 degrees. How tall is the smokestack? All right, so they give us smokestack. This is a picture they're giving you. I'm just basically copying it. This is my shadow. This is the smokestack. I have a sun. Then I've got my angle of elevation here. And this is 38 degrees. Oh, the shadow was 1,580 feet. Now, they also tell me that this angle here is 38 degrees. Do you know why?
One of those rules that we learned some time ago that I don't remember the name of, but I recognize why it works.
Well, alternate interior angles.
That.
They're equivalent, okay, so that's why. Now, they gave that to you, so you wouldn't have had to know that. It just would have done it, but yes, it is a thing back from geometry.
Ugh.
It doesn't disappear.
That explains why I don't remember what it's called.
And I'm trying to figure out how tall this smokestack is over here. Okay, so I've got my triangle, my shadow, length is here, angles here. So, any guesses on what trig function goes with this one?
Tangent. I didn't even look, I just guessed by the way you said it.
So the tangent of 38 is equal to x over 1580. So x is equal to 1580. Tangent of 38. Pigs,
Pigs?
cows,
Oh, feet.
feet, thank you. I want you to get in the habit of saying the unit so you don't forget them.
Pardon? I actually barely eaten today. Thank you very much.
That's why I was like, I'm going to say something super obnoxious so that she'll realize she needs to say units.
I mean, it obviously worked.
You were like, what? All right, now I'm going to jump back to number 3 since we've done that one. You'll see why in a second.
Does it not use tangent?
No, it does.
It has to do with the alternate interior angle.
All right, so finding a distance. The angle of depression. So again, I'm just writing mainly what you need. The angle of depression from the top of the Smoketown lighthouse. I'm just going to write of the lighthouse. 120 feet above surface of the water to a buoy is 10 degrees, and that's a weird word to spell if you don't know how to spell it already.
It's like boy, except you put a U in between the B and the O.
Yep. How far is the buoy from the lighthouse? So we got an angle of depression of 10 degrees, and it's 120 feet above the surface of the water. Trying to figure out how far it is from the lighthouse.
Looks like a rocket ship.
Yeah, I was thinking the same thing. Like at first it looked like a really tall and skinny volcano, but then you put the top on it and then now it's a rocket.
Y'all heard the joke about the teacher who was on the Challenger, right?
No.
Did you know she only blew up in front of her class once?
Oh my gosh. That is
My dad tells that joke all the time.
Does he really?
Yeah.
That's crazy.
But yeah, it's so funny.
I don't know if
This is
it's
the
okay
fact
for
that
me to
it's so
laugh.
bad makes it funny.
Huh? What'd you say?
So the fact that it's so bad makes it so funny.
Yeah.
Like, I don't know if it's okay for me to laugh at that, though. Like, I feel bad.
I laugh every time. My dad told it literally while we were at the Space Center in Houston.
Oh my gosh. One day you're gonna run into one of the students. They're gonna be like, I can't confirm. You are right.
This is a nice little picture we have here.
I do my
What's that
best.
circle?
It's giving the American flag. It was different colors and had a lot more stars.
Oh, that's a buoy. I'm probably gonna call it a buoy, so I remember how to spell it, you know? Buoy. Go hear the bird.
I don't know what's worse, my drawing or my math. This buoy's looking. My lighthouse does not look like a lighthouse. That's a round ship. It looks
Like a what?
a thumb, like a thumb that's like, you know, the toe thumbs. Yeah. It looks like a toe thumb with a ring on it.
Mine kind of looks like a person wearing like some sort of coat and a scarf and like this hat. Like here, look at it.
Which one?
The tall one. I haven't looked at it.
All right, this is all what's given to you.
That's a lot.
Just so you know, on the test, I won't give you quite so pretty pictures.
Okay.
You'll get to see our artistic abilities, I guess.
I'm gonna spend like, I'll be here like the next class period, so I'm drawing everything.
So is there like some sort of like adjacent angle thingy?
Well, I'm trying to figure out this distance here.
So I guess we could just do like the interior angle thingy.
Yes, I can. Okay, so we know this is 120 feet. We know that this also has an angle of 10 degrees. This base x is what I'm trying to find. So, of what?
You sound so worried.
Of 10
Equals.
equals 120 over x.
Yep, just swap it. So x equals 120 over the tangent of 10.
That's a big number. Well, I've seen bigger. It's still a big number. 680.55 feet.
We didn't have to do cows this time. Now, I'm going to tell you that when you check your answers in the back, you're often going to see them use cotangent.
Oh.
But it doesn't really make sense. They use it because they want to solve for the piece that's on top. So they were going to use cotangent so that it would have been x over 120. But you know how to solve these, so you don't need to do that. Just use tangent. Because
Yeah,
cotangent you have to type in differently. Like tangent, there's a button for it. So
Yeah, it's nice seeing such a small number make something else so big.
all right. Let's Jump to 10. A ramp leading to a freeway overpass is 470 feet long and rises 32 feet. What is the average angle of inclination of the ramp to the nearest 10th of a degree? All right, so got a triangle here. Rises 32 feet. The ramp is 470 feet long. So what is the average angle of inclination? So this one's a little different.
That's fine, I'm okay with it.
So what do I need for this one?
Sine.
Sine. So sine of theta equals 32 over 470. Take the inverse. 32 over 470.
Degrees.
3.9 degrees. All right, I'm going to jump again to number 20. A ranger spots a fire from a 73-foot tower in Yellowstone. She measures the angle of angle of depression to be 1 degree, 20 minutes. How far is the fire from the tower? It was interesting. I don't remember if it was this summer or if it was last summer, but we went somewhere and we went on this like hike, and we actually went up to the top of a tower where somebody is designated to be there to watch for fires. And I thought that was so interesting because I had done this problem several times with classes, and I was always like, there's no way you could actually like spot like a fire from like this tower.
Yeah.
But anyways, this one person like literally like stopped like a wildfire from starting because they were able to see it and catch it so quickly that they were able to get to it in time to prevent a wildfire from starting. from this tower. I don't even remember where it was. But I just thought it was really interesting because you don't like hear about these things until you know you're like doing a math problem or something. So I was like, oh, like this is legit. This isn't like just made up for the sake of a math problem.
Or you know, like buying 37 lunges.
Yeah, exactly. Like what?
I mean, I can think of some scenarios where that is realistic.
Not often, but
Yeah.
occasionally.
Yeah.
All right, so we're going to have basically the tower here. Now, this one doesn't give you a picture, but we're going to have our tower.
Is the dot the person?
No, I'm just making the dot like the edge of what's going to be my triangle.
Oh.
My little fire. Didn't get obnoxiously large because, you know, she caught it in time. Now, the tower is 73 feet tall. Now, I'm going to draw my triangle this way for the sake of seeing this angle of depression, which is not drawn proportionately whatsoever because it's 1 degree, 20 minutes. So,
Yeah, that's fine.
but this is going to be my angle. So the 73 is actually going to end up over here. But I'm trying to find this length here. How far is it from the tower? So what's the first thing I need to do? So 1 plus 20 over 60 should be like 1.33, I think. Repeating, but now what?
Maybe we use
Tangent of what? Is equal to 73 over x. So x equals 73 over the tangent of 1.33. It's pretty far away.
how she was able to see that. That's some really good vision.
They have like binoculars at the top of those towers because they actually, it's like, I mean, the tower is like an indoor thing, like you sit in it. But every so many minutes, I think it's like every 15 minutes, they have to go out and walk it, like walk around to the outside of it to look
Maybe
and
there's,
see.
like, maybe it's like a mini telescope.
No, they were like actual binoculars that they had. But there was the one that I was at, they had seen a lightning strike hit. And so they were watching, and that's how they saw the fire start. Because that's actually how a lot of, like, the wildfires end up starting, from my understanding, is from, like, lightning strikes and stuff. Mm-hmm. So I think they almost said that they check more frequently when they're in, like, a bad storm, but they try to check from inside the towers. They don't have to go, like, outside and, you know, risk their lives. And but, anyways. All right, I'm going to give you a couple problems. I'm only giving you, like, 3 for practice. But if you feel like you need to do more, I would just say go through and pick a few more. But I feel like you've pretty much gotten it down, other than, like, maybe if I don't give you the picture, you might have a little bit of a harder time setting it up, but...
So is that all for the section?
Yeah, so you'll have tomorrow, you can work on it, and then we're going to quiz on Friday, unless y'all feel like you want to take it on Thursday and get it out of the way if you feel like you got this stuff down.
I I'd rather not take it on Thursday.
Yeah, you're taking a stats test on Thursday, so probably not.
I had no reason. I just.
No, that's fine. I just was like, it's AP, so we can, and I know sometimes if you have like a ton of other stuff, you might want to take it, but. Anyways.